Hey guys, welcome to another theory of computation tutorial. Today we'll look at another example of converting a milli machine to Murray machine. So let's get started. Alright, so this is the example. Convert the following milli machine that gives 2's complement of any binary input string to its equivalent Murray machine. Okay, so this is the milli machine that gives 2's complement of any binary number. Now first thing you need to know is what is 2's complement. Okay, so let's say we are given this number 1, 0, 0. How do you get its 2's complement? So the steps is first you get the 1's complement. Okay, 1's complement. So 1's complement means you just invert the number. So if it is 1, you make it 0. If it is 0, you make it 1. So 1, you make it 0. For 0, you make it 1. So this is your 1's complement. And how you get 2's complement? You just add 1 to it. So plus 1 you do. Okay. So 1 plus 1 is going to be 0. Carry forward 1. So 1 plus 1 again becomes 0. Carry forward 1. And 1 plus 0 is 1. Okay, so this is how we get 2's complement. So 2's complement of 1 0 0 is 1 0 0. Okay, now this machine does the same thing for us, but you have to go from right side to left side. Okay, so basically you have to input from your right side to your left side. Okay, now we have to convert this milli machine to its equivalent Murray machine. So what we'll do is we'll start with our starting state. So we have got our starting state A. Now remember, in milli machine, the output is dependent on the output plus the the input plus the state, whereas in Murray machine the output is only dependent on the state. Okay, so let's say we have got starting state A. If you get input 0 in starting state A, you are going to get to state A itself, and the output is going to be 0. So let's say if you get input 0, you are going to state A where the output is supposed to be 0. So we will write the output as 0 here. Okay, now if you get input 1, you are going to go to state B where the output is supposed to be 1. So let's write that down. So if you get input 1, you go to state B. Okay, and the output is supposed to be 1. So let's write that down. Output is 1. Okay, now what happens in state B if you get input 0? So if you get input 0, you are going to state B itself where the output is supposed to be 1. Okay, so if you get input 0, you are going to a state B where the output is 1. Fine. What about if you get input 1? So if you get input 1 over here, you are supposed to go to a state B where the output is supposed to be 0. But we have already assigned the output 1 over here. So you can't go to this same state. So you have to create a new state called state B1. Okay. So what we can do is we can just call this state B0 and we'll create a new state called B1. B1 where the output is, where the input is going to be 1 but the output is going to be 0. So if the input is 1, the output is going to be 0. Okay, so are we done with this? No, because for the state B1 we have not mentioned what happens if you get input 0 or 1, right? So if you are in state B1 and you get input 0, you are supposed to go to a state B where the output is supposed to be 1. So this is the state B where the output is 1, right? So if you get input 0, you are going to state B with output 1. Okay, and if you get input 1, you are supposed to go to a state B with output 0. So this is the state B with output 0. So if you get input 1, you are going to a state B where the output is supposed to be 0. So now our Murray machine is complete. Okay, so what we can do is we can just fill in this equivalent transition table. So let's say first we'll write down the states. So we have got state A, then you have got B0 and you have got B1. Okay, now what are the outputs associated with them? A, the output associated is 0, B0, the output associated is 1, and B1, the output associated with it is 0. So let's write that down. 0, 1, 0. Okay, if you get input A, okay, instead of A, it should be 0 and 1. Okay, 0 and 1. Yeah, so if you get input 0 in state A, you go to state A itself, and if you get input 1, you go to state B0. Okay, and state B0, if you get input 0, you go to state B0 itself, and if you get input 1, you go to state B1. And in state B1, if you get input 0, you go to state B0, and if you get input 1, you go to state B1. Okay, yeah. Now we'll try to pass some strings like this 1 0 0 from in both milli machine and Murray machine to see if it is actually working or not. Okay, so let's pass this string 1 0 0 through the milli machine first. Okay, So Mealy machine, let's change the color of the pen. Let's make it red. All right, so let's say we are given the string 1 0 0. As we have said, we start from the left to right. So let's say you are in state A, okay, state A, and you get input 0. You go to state A itself, okay, and the output is going to be 0. Okay, now in state A again you get input 0. You go to state A itself and the output is going to be 0, correct? You're going to state A itself, the output is going to be 0. And then you get input 1. You go to state B, okay, and the output is going to be 1. You go to state B and the output is going to be 1. So we have got our 1 0 0 as the 2's complement. Is it correct? Yes. So for Mealy machine it is working. What about Moore machine? So Moore machine, okay, let's change it to blue. Okay, so let's say you have got this string 1 0 0. Okay, why is the color not changed? Oh, my bad, I selected green. Okay, so let's say now in Moore machine what happens, you get an extra bit because it is always n plus 1. Okay, so let's say you are in starting state A over here. Okay, automatically the output associated with A is 0. You're getting already an output 0. Okay, now in state A, if you get input 0, from left to right you are going, right? If you get input 0, you are going to state A itself, where the output is associated with this 0. Okay, now again you get 0 over here. You go to state A itself. Okay, the output associated with it is 0. And then you get 1, you go to state B0. B0. Okay, and the output associated with B0 is 1. Okay, so you just ignore this bit and this is your correct output, 1 0 0. Is it correct? Yes. So the Moore machine is working as well as the Mealy machine for our 2's complement. So I hope you got this concept. If you have any queries, feel free to ask me in the comment section below. Thank you very much.